Hello, in today's video we will understand the meaning of equivalent resistance of a combination of resistances. Sometimes number of resistances are connected in a circuit in order to get a desired value of current in the circuit. Resistances can be connected in series combination, parallel combination and in mixed combination. So let's study these combinations in detail. The series combination of resistors first. You can see in the figure shown on the screen that the two resistors are connected end to end, means the same current which has entered in the first resistor is flowing through the second one. Now one more resistor is connected and you can see that the R1, R2, R3, the three resistors are connected end to end. So such type of combination is known as series combination. So that means if the number of resistances are connected end to end so that same current flows through each one of them in succession, then they are said to be connected in series. Let's calculate the equivalent resistance mathematically. For this, consider the first figure of last slide. The two resistances connected to a potential difference V and through them the current I flows. As the combination is a series combination, so the same current will flow. So by using Ohm's law, the potential difference across R1 will be equal to V1 and it will be equals to I into R1. Similarly, the potential difference across R2 will be V2 and that will be equals to I into R2. But the given potential was V. That means V is divided into V1 and V2. So the net potential V, we can say that it is the sum of V1 and V2. So by putting the values of V1 and V2, we got V is equals to I into R1 plus R2. And from here, V by I will give you the net resistance R1 plus R2 and it is said to be the equivalent resistance. Similarly, if we consider the second figure of the last slide and calculate the equivalent resistance, you will get R1 plus R2 plus R3. So if you have n resistances, then the equivalent resistance in series combination will be Rs. S will be the subscript and that denotes that it is a series combination. And that will be equal to R1 plus R2 plus R3. And here Rs, the series combination, is greater than the greatest of all. Means if you have the value R1 equals to 1 ohm, R2 equals to 2 ohm and R3 is equals to 3 ohm, then the Rs will be equals to 1 plus 2 plus 3, that means 6 ohm, and 6 ohm is greater than 1, 2 and 3 ohm. Or you can take any another example. Now let's understand the parallel combination of resistors. If a number of resistances are connected in between two common points so that each of them provides a separate path for the current, then they are said to be in parallel combination. As shown in the figure, there are two resistors R1 and R2 having resistances R1 and R2 and they are connected between two common points A and B and they are connected to the potential difference source V and a current I flows at point A and then it divides into two parts, I1 and I2, and at point B again I1 plus I2 becomes equals to I. So here you can see clearly that the potential will remain same, but the current is divided, and the net current I will be equals to I1 plus I2. Again, by using Ohm's law, you can find out the potential across the resistances R1 and R2, and that will be equivalent to V, because the potential will remain same. So for the R1 it will be V equals to I1 R1, and for R2 it will be V equals to I2 R2. From here, find out the value of I1 and I2 and put in the equation I is equals to I1 plus I2, and you will get V into 1 by R1 plus 1 by R2. So if the combination is replaced by equivalent resistance R subscript P, here P denotes the parallel combination, so we get I is equals to V upon R equivalent or RP. So you got 1 by R equivalent or 1 by RP equals to 1 by R1 plus 1 by R2. Similarly, for the second figure, you can calculate and you will get a 1 by R equivalent will be equals to 1 by R1 plus 1 by R2 plus 1 by R3. Now you can see that as 1 by Rp is equals to 1 by R1 plus 1 by R2 plus 1 by R3, and by taking any example, by taking any values of R1, R2 and R3 and putting in this formula, you will get Rp will be the smaller than the smallest of all. You can consider the same example, R1 as 1, R2 as 2 and R3 as 3 ohm, and find out the value of Rp. It will be less than 1 ohm. Now here you can see that there is a mixed combination. In the first figure, R1, R2 and R3 are the three resistors having resistances R1, R2, R3, and in this identify whether which one are in series and which one are in parallel combination. So you can see that among R2 and R3 the current is dividing, so they are in parallel combination. So by following the same procedure, we got 1 by R equivalent of 2, 3 equals to 1 by R2 plus 1 by R3. So therefore R equivalent of 2, 3 will be R2, R3 upon R2 plus R3. Now the situation will be according to the second figure. Here R1 and R equivalent. So now these two are in series combination. So the net R equivalent of 1, 2, 3 will be R equivalent of 2, 3 plus R1 as shown in the third figure. Now if in any situation, or we have discussed in the last slide, if the potential is also given to you V, then you can find out the current value by using Ohm's law. I is equals to V upon R equivalent. Put the value of R equivalent, put the value of resistances, potential, and you will get the current. Now let's do a numerical problem based on these combination of resistors. A 16 ohm resistance wire is bent to form a square, and a source of 9 volt EMF is connected across one of its ends as shown in the next slide, and you have to find out the current drawn from the source and the potential difference across the C and D. Now the second situation is, if now the wire is stretched uniformly to double the length, and once again the same cell is connected in the same way across one side of the sphere formed, what will now be the potential difference across one of its diagonals? Just pause the video and try to solve it, and then find the solution and get it matched from the next slide. So from the figure you can see that the net resistance that comes out to be 3 ohm. How? From 9 volt a current will travel towards point A, and at point A it is divided into I1 and I2, and one portion of this current will move from A to D, D to C, and C to B. That means the resistances across the arms AD, DC, and CB are in series combination. And the series combination resistance will be 12 ohm, because in the question it is given to you a 16 ohm wire. So the value of R is 4 ohm for each. So this 12 ohm resistance is now combined to the AB wire of 4 ohm resistor in parallel combination. So the net equivalent will be 3 ohm. So by using Ohm's law, you can find out the value of I equivalent equals to V upon R equivalent. So the net value of current will be 3 ampere. Now, according to the question, you have to find out the potential difference across the CD, and that we will denote by VCD, and that will be equals to ICD into RCD. You know the value of RCD is 4 ohm, and the value of current will be 3 upon 4, because the total current we have calculated 3 ohm. So you got the potential difference equals to 3 volt. And now in the second part it is said to you that the wire is stretched to double of its length. So each resistance becomes 4 times. And you can calculate the potential difference then, and then it will become 6 volt. Try to solve more questions from your NCERT solved examples as well as a back exercise, and I will give you such type of questions in the assignment also. Try to solve those also, and if you have any problem then ask from your teacher. Thank you.